Algebraic fractions. There is no difficulty seeing that the common denominator of the fractions is 12. Whenever we have denominators that do not have common factors, we are sure that the common denominator, which is the LCM of them, will be the product of the two of them. 4 times 3 is 12. The common denominator is 12. And what do we do next? 3 into 12 is 4. 4 multiplied by x minus 2. Then 4 into 12 is 3. 3 times all of x plus 1. Expand the brackets. We have 4 times x is 4x. 4 multiplied by negative 2 is negative 8. 3 times x is 3x, and 3 multiplied by 1 is 3. After that, we will put the like terms together. What do we know? 4x plus 3x is 12x, and negative 8 plus 3 is negative 5. 7x minus 5 over 12. Binary operation. And that is our expression of the binary operation. To cause the binary operation to operate on the numbers, just substitute the numbers in the place of the symbols or letters in their respective places. The binary operation is operating on 3 and 4. So 3 plus 4 is equal to 7. We square 7. Then 2 times 3 times 4. So square 7, we get 49. 2 times 3, that will be equal to 6 times 4 is 24. So we will have, in the end, 49 minus 24, and that is equal to 25. Factorization. In the process of factorization, we take the highest common factor of the terms and divide each term by the highest common factor. In this case, we have the highest common factor is xy. So we take xy as the highest common factor, and we will say what? Xy cubed divided by xy. X squared y divided by xy. So we have xy cubed divided by xy, that is y squared, and x squared y divided by xy, that is x. Under examination conditions, it is not necessary to include the intermediate step. I am only here demonstrating the fundamental principles of factorization. Here, the principle is the same, but we will use factorization by grouping, in which we factorize in pairs. Take the common factor of the first pair. So we have 2h is the common factor of the first pair. We divide each term by 2h. Divide the terms by 2h. In the second case, the common factor is negative 3k. So we take negative 3mk and divide by 3k. We are dividing each term by the common factor, as we have that right there. So take the common factor of each term and divide each term by the common factor. I'm sure it is quite visible what we have right here. The terms are returning here, and we are dividing by the common factor. We have the terms returning here and here again, and we are dividing by the common factor. In the end, 2h will cancel, we have m. 2 and h will cancel, we have n. And on the other side, we have something similar. But do not forget that we are dividing by a negative quantity. Negative divided by negative is positive, and positive divided by negative is negative. We will take it a step further by doing the same thing again. finding the common factor, which is m minus n, as we can see, and we are dividing each term by the common factor. No doubt, m minus n, the common factor, we see that this is divided by m minus n. We divide again this term by m minus n. And quite simple to see what will happen. In the bracket, we will have 2h minus 3k. That is all that will remain when we divide each term by the common factor. So m minus n, 2h minus 3k. This is what we are accustomed to and what is required under examination conditions. In one step, we will write down the common factor, and the result of dividing the terms by the common factor will be placed in brackets, like so. And we imagine that this is a one-step problem because usually CXC gives only a single mark for a factorization problem like that. So we are sure we should be able to do it in one step. So take the common factor and then we say x will cancel x, y into y cubed is y squared. Then down here we say x into x squared is x, and the y's will cancel. And we are expected to do it like this in the examination. What we had on the previous slide was illustrations of the fundamental principles of factorization, in which we are demonstrating that we need to take the common factor and divide each term by the common factor. The simplified version of this problem is also here. In the first step, we will factorize the first two terms by taking a common factor, and we will do the same with the second pair. Common factor we know already to be 2h. 2h will cancel with 2 and h, m. 2h will cancel with 2 and h, n. Then we have negative 3k. Negative into negative is positive. No doubt we have this positive m right here. The 3k, the 3 and the k. Then down here, negative 3 into positive is negative. So we have negative into positive is negative. 3k will cancel with the 3 and the k, and we have n. But we are not done yet. We are expected to see that the common factor is m minus n, and that the other bracket will be comprised of 2h and negative 3k, like so. Do not forget that in the second pair, the common factor is negative, like this. Dividing the second term by it, we'll get 3nk divided by negative 3k. Positive divided by negative is negative. Positive divided by negative results in a negative. When factorizing, we need to be mindful that division should not be without the consideration of signs. If y varies directly as x, then y is equal to the product of x and the constant of proportionality. Y varies directly as x, then y is equal to the product of the constant of proportionality and x. Y is equal to the constant of proportionality multiplied by x. Usually, our first step is to determine the constant of proportionality. This is not very difficult because initial values of the variables x and y are already given to us. First, find the constant of proportionality. That is not difficult because initial values of x and y are already given to us. All we need to do is just substitute those values in this expression. So 12 is equal to k multiplied by 2, and the simple process of dividing by 2 results in k is equal to 6. According to the information in the table, we have the value of x given as 5, and we need to determine the value of y that is given as a. We will make use of the same initial equation. As long as we have established our relationship, that is the same relationship that we use on every single occasion. So y is equal to kx. What do? Substitute a for y, 5 for x, and k is equal to 6. A is equal to 6 multiplied by 5, and that is equal to 30. There is no difficulty with that. Finally, the value of y is given to us as 48. B is our value of x, and we already know the constant of proportionality, that it is equal to 6. Use the same relationship, substitute the known values. The only unknown in this particular case will be b. Transpose by dividing by 6, and the answer is b is equal to 8. There's nothing to it.